So each vector has a magnitude. Okay, what's magnitude? Length. When you see magnitude, think length. So we want to talk about the magnitude and direction of the vector. Okay, so the standard assumptions, the tail of the vector is at 0, 0. And so you see this picture over here. Theta is measured in the standard way. It's measured from the positive x-axis. So the angle that we're referring to here is the angle of the arrow that the vector v makes with the positive x-axis. And it's the usual thing. If you create theta with a counterclockwise rotation, theta is positive. If it's a clockwise rotation, theta is negative. Okay. So what's the length of this thing going to be, you guys? The length of this vector in red? I kind of break this class up into major themes. The very first major theme that we talked about, remember, was the Pythagorean theorem, right? Yeah, the next major theme is the 6 trig functions. We're back to the Pythagorean theorem, aren't we? Yeah. These ideas, SOHCAHTOA is another major theme. These ideas repeat over and over again in trigonometry. And many of them in math as well, in algebra, that is. So if you drop this perpendicular and create your friend, the right triangle, then again, now this time I'm going back and forth. Just for simplicity, I'm representing the horizontal component of V with A and the vertical component with B. I'm fickle that way. And so you could think of the length of that side as A. The adjacent side to theta is A. The opposite side you could think of as B. Keep in mind, A and B, if you're in another quadrant, A or B or both could be negative, right? So they could be directed lengths. But that's not going to matter for the length of the hypotenuse, which is the arrow itself. So what's that length going to be? By the way, we're going to assign that a notation. Magnitude V is represented by double vertical bars. So the length of V is represented by double vertical bars. So if I write this down, you're going to think length or magnitude of V. Some books use single vertical bars, and you don't get that confused with absolute value because you know it's a vector, not a number, but your book uses double absolute or double absolute value? No, double bars. So what's the Pythagorean theorem say then? That the length of the vector in red should be? Yeah, you got to remember to take the square root, right? But yeah, square root of a squared plus b squared. And again, that works because the initial point, the tail of the vector is at the origin. Okay, so in this example, let u equal -3, 5. Let's find the magnitude. So when you read this, think magnitude of u or length of u. Let's find the magnitude of u and the direction angle theta. So what does the formula tell us that the magnitude should equal? Well, it's the sum of the squares of the components, and then you take the square root, right? That's essentially what it said. So what would that look like? The square root of? Well, -3 squared, right? So that negative is going to go away. You don't have to worry about it. So plus what? Plus 5 squared. So all that's going on underneath the root. So what does that give you? The square root of? So 9 plus 25, 34. And so that's it. That's the length or magnitude of u.